This video is a test. It's the first in a series of videos that I want to make digging deep into React Native libraries that focus on delighting the user, adding animations, graphics, visualizations, that sort of thing. The kind of thing that as a web developer, I was really good at, but which is hard to get right in React Native. This one is about React Native Reanimated. We don't explore the whole API. Instead, we dig into its implementation and try to understand how it works. This video isn't about creating the most amazing animated interface, though I want to get to that. It's about understanding our tools, understanding how React Native Reanimated works under the hood so that as things get complicated, we have a good mental model of what's going on so that we can debug and reason and be creative and be performant, all those good things. We are going to look at some code. We're going to walk through it step by step, really try to understand it. But before we get to that, I want to go through a couple key reanimated concepts. If you've used the library, these are things that you'll know about, but you might have a bit of a fuzzy idea about how they work exactly. The idea is to remove that fuzziness so that when we get to the code, everyone's on the same page. Reanimated's first load-bearing concept is that of the shared value. This is the library's building block. Let's start with the name, shared. Shared between what? It's actually a reference to React Native's threading model. In React Native, there are two key threads that handle the rendering of our app. First, there's the JavaScript thread. This is where our TypeScript runs. This is the JavaScript runtime that React uses, typically to determine the nodes, the elements that need to be drawn to the screen. Being JavaScript, though, it can't actually draw UI elements on the screen. All it can do is create a data structure describing the desired UI and hand it off to the second thread. Now the second thread is the UI thread. It consists of native code on Android. It's Kotlin and Java. On iOS, it's Swift and Objective-C plus C++, which runs on both. The UI thread is the only thread that can actually draw to the screen and access other native device functionality directly. So it takes the data structure describing the UI from the JavaScript thread and draws it to the screen, among many other things. So a shared value is shared between these two threads, and they're shared via something called the JavaScript interface, or JSI. Introduced with React's new architecture, the JSI allows JavaScript to directly and cheaply reference C++ objects and invoke their methods, and it allows C++ to do the same in the other direction. So these shared values are turned into JSI host objects, which allow for this fast access to data across threads. Why you would want to do this is something we'll get through as we step through our code. Reanimated's second load-bearing concept is the worklet, another odd name. A worklet is a JavaScript function which can be invoked by the UI thread on a second JavaScript runtime, which Reanimated spins up specifically for the purpose of running worklets. We'll get to why, but first, how does it do all this? Reanimated actually has a Babel plugin, which before runtime, when your app is being built, looks through the code for functions that are either marked with an explicit worklet directive or functions that are passed to a reanimated hook, which always workletizes the functions passed to it. So use derived value, use animated style. Nearly all of them do this. If you're passing a function to a reanimated hook, it's probably being workletized. The Babel plugin gathers any context that function requires, variables, references to shared values, and then serializes both the worklet function and that context, turns it into a string of text. Now, this string at runtime gets passed through the UI thread, through C++, to this second JavaScript runtime, which then deserializes both the worklet function and its context. The JavaScript engine interprets the string, turning it back into usable code, and then it registers it with Reanimated so that it's ready to be called by the UI thread when required. So why does it do all this? Well, these worklets are typically used to calculate and recalculate things like UI styles whenever the shared values used in those styles change and change and change and change. In other words, they get run a lot, 60 times a second if your device runs at that clip. So executing them on a separate minimal JavaScript runtime makes a lot of sense. The main JavaScript thread has a lot going on, it's very busy, and the UI thread needs these values calculated to the millisecond. So that's worklets. JavaScript functions invoked by the UI thread on a second JavaScript runtime spun up for that purpose. It's a lot, but having a firm grasp of these key concepts is going to be really important as we step through our code and see them in action. Speaking of code, our little example app. Here it is. It is simple, a body mass index calculator which animates a visualization of the user's height, weight, and BMI, good or bad, as they enter their numbers. The animations aren't anything exciting, but just about everything in Reanimated builds on is a complication of these fundamental bits and pieces. If we can understand how this bit of code works, we can understand the library's essentials. And the library's advanced APIs build on those essentials. Okay, so this is a basic outline of our React Native architecture. We have the main.js thread here, we have the UI thread here, and the additional runtime spun up by Reanimated. So what I want to do here is move step by step through some basic actions in my sample app to demonstrate how Reanimated works, how its work is distributed across the threads so that we get a better understanding of the library and React Native more generally. First, I'm going to look at our JS code. I'm going to pull out the key parts, and then we're going to see what happens when we have our initial render and then when we perform some actions in this simple BMI app. So let's start by diving into this JS code. As we go and as I talk to them, I'm going to pull out the most important parts. First, we have two shared values, weight and height out here. So first thing I'm going to do is pull them out. Let's have weight up here and height here as well. Now I'm going to keep the shared values generally in black text, and I'm going to use other color schemes to signify other important bits of our code here. So we have two shared values up here, and they feed into a variety of derived values and other sort of kinds of varieties of derived value. So first, in our BMI app, we have the BMI here. We'll pull that out in a moment. That feeds out into some animated props, which I'm calling BMI text, because that's what we use to animate the BMI text. And then we have viz style, the details of which aren't so important. Don't worry about these numbers so much. But what's important is that we're animating the width to symbolize the weight. We're animating the height to symbolize the height. And we're animating the background color to symbolize whether the BMI of the user is unhealthy, in which case it's red, somewhat healthy, in which case it's this borderline yellow, and then we have healthy, which is a nice green. Alrighty, there we have our derived value and our other worklet defined values. We have a couple other things, two animated elements. We have an animated view for the rectangle, that is most of the visualization. And then we have an animated text input, which animates the text inside that view. So we're going to pull them out as well because they have a sort of special role here. Animated view, animated text input. Great. Okay, we are ready to go. Let's start at the beginning. In fact, let's start before the beginning. As mentioned, the first thing that's going to happen to our JS code is that during the build phase, these derived values, these values that are the result of the execution of worklets, those worklets get serialized. So let's symbolize that. I have this nice emoticon here. Here we go. We have 3 serialized worklets. These functions are turned into strings of text. The context, the variables outside those functions that they use are included in that text. In this example, BMI uses weight and height, so a reference to those shared values is included. Viz style also uses, let's zoom in here, a couple variables that fall outside the worklet, this input range and output range. So those will be serialized along with the function body itself and these functions that it uses, clamp and interpolate color. Okay, so what's the first thing that happens when the screen mounts? the very first thing that happens is the initialization of our shared values. So let's start by doing that. Oh. So I'm going to draw them clumsily, traversing the JSI to indicate that they are shared, cheaply accessible across both the main JS thread and the UI thread, and in fact across the additional JS runtime, by the way. And these get initialized with their initial values, which I happen to know. So in the code, it's a constant: initial height, initial weight. The initial weight is 80, which just happens to be my weight, and 1.83 meters, which is my height. The next thing that happens is the deserialization of our worklets. So to symbolize that, let's run down here. So again, they get passed, these strings of text, these serialized functions get passed through the UI thread, through all this C++, to this additional JS runtime spun up by Reanimated. Okay, we have BMI text, we have viz style. Gonna spread them out a little bit. Okay, so these functions are deserialized, turned from serial back into wheat, or in reality, from a string with associated context back to functioning code. The string is evaluated, the functions are now ready to go, or almost so. The other thing that needs to happen is that these worklets need to be registered with Reanimated so that they can be executed by the UI thread. Let's symbolize that by underlining them there. As these worklets are being deserialized and registered with Reanimated, a dependency graph charting the dependencies, the relationships between these different values is constructed. So let's do that now. We're going to start with our shared values. So we have weight here, and we have height. Now they're not dependent on anything. They're independent nodes in the graph. And then we have our first derived value. So BMI, that is calculated using both the height and the weight. And then we have our animated props, which is another these worklet calculated values. That is dependent on BMI alone. And then our final derived value is viz style. Our animated styles, which are derived from both the weight, height, which are used directly in the styles, and BMI, which is used to determine the color style. After the dependency graph has been constructed, we have the initial execution of our worklets. So for BMI, I believe the initial value is something like 23.5. BMI text, we have an object, which ultimately boils down to 23.5. And then the viz style is a more complicated object. We have a width and we have a height. And then we have a background color, and initially 23.5 is a healthy BMI. So that's a nice shade of green. So once all these values have been calculated, we have our initial rendering. And for that purpose, I want to bring our animated views over here to the UI thread. Now, of course, there are parts of the implementation of both of these that exist on the JS thread, but they ultimately boil down to native views. The key thing, and the reason why I'm bringing them over here, is that now that all these values are calculated, they can be applied to our animated elements without a round trip back to our JS code. So normally, say if you were going to change the background color of a view or animate a change in the background color, you want to change it 50 times across a gradient from red to green, you would set that in the on the JS thread. You would set it as a style. You change it 50 times. every one of those 50 times, React is reconstructing its data structure, describing the UI that needs to be rendered. It's passing it from the JS thread over to the UI thread, which ultimately renders it. What Reanimated allows us to do is to reflect these changes in our UI without making that round trip. The values get changed on the UI thread or from worklets that are invoked by the UI thread, and they're applied directly to these components. Our animated styles come over here and they get applied to the view, and the animated props, they jump over here as well and they get applied to the text input. Again, without the round trip to the JS thread. And the application ends up looking something like this. Let's get animated. Let's say the user changes the weight from 80 to 90. We have two text inputs here, one of them feeding the weight, one of them feeding the height. And let's see what happens when the weight gets changed. So these are our inputs. We have weight and we have height down here. When the value is changed, we get that value. And with timing, after the specified duration, set the value to whatever the user has input, converted to a number. In other words, the weight value doesn't get set to 90 in this case right away. Instead, we essentially give Reanimated a destination, in this case 90, and some instructions as to how to get here, in this case a duration of 1 second. And then Reanimated schedules a series of updates according to our instructions. In our case, we have 1 second, so that's 60 updates across that second if we're aiming for 60 frames per second. So that's 60 times that weight is changed and 60 times that the values derived from weight that use weight are updated, and 60 times that our native animated views are updated without a round trip to JavaScript. So let's go through and see how that happens. So we've got our destination here. Let's update our shared value to start with. Let's say we move up to 80.5. Fantastic. What happens next is that we need to look at our dependency graph, because we don't just want to update all our values, even those that potentially don't need to be updated. For example, the height is still the same. We don't want to recalculate worklets that are exclusively dependent on the height, if such worklets existed. So we look at our dependency graph and we mark all of those derived values that are dependent on weight as dirty. So we have BMI depends on weight. BMI text depends on BMI, which depends on weight. So that's dirty as well. We have viz style. That's also directly dependent on weight. Once all the nodes in our graph that need to be re-executed have been marked as dirty, we go through and we re-execute them. So starting with BMI, update this value. We're going up in weight, which means that the BMI will increase. And then we execute BMI text. Again, that tracks with BMI here. Viz style also dependent on weight, so we re-execute that as well. We're still in the healthy range though, so our background color remains green, but the weight and the height are updated. This is just one frame in our animation, but without a round trip to the JS thread, we can apply the BMI text again to the text input, and we apply our animated styles to our animated view. Again, crucially, without a round trip to the main JS thread. So that's our first frame. We're just going to very quickly go through the second frame and then skip to the end of the animation just to nail down exactly what's going on, reinforce what's happening at each stage. The first thing that happens, our shared value gets updated as scheduled to 81, let's say. And then we go to our dependency graph. Weight. What are the dependent nodes? BMI is dependent directly on weight. BMI text is dependent on BMI. Viz style is also directly dependent on viz style. So we need to recalculate, re-execute these worklets again to get the updated value for this second frame of our animation. So we execute BMI. Again, we're slowly moving out of the healthy range ever so slightly. 24.3, then we execute our BMI text, 24.3, and then we re-execute our viz style. And again, we're still in the healthy range, so we have this green, but our width and height get updated. These updated styles are then, well, firstly, the BMI text, the animated props get applied to our animated text input without a round trip to the JS thread, and the viz style likewise gets applied to our animated view without a round trip to the JS thread. So this process keeps repeating until we get to our final destination of 90. In our case, we're animating across 1 second. So if our device can handle it, this will be executed 60 times, slowly incrementing the shared value and the derived values that depend on it, reapplying the associated styles directly to the animated components. I'm not going to go through all those steps, but I will just quickly update the board so that everything looks as if I did. Okay, let's get the user to do one last thing just to reiterate the point. Let's say that the user changes the height from 1.83 to 1.5. Again, we have our height text input here, and we have a handler. It's very much the same story here as to how the value gets assigned. The shared value is assigned the value that the user enters, converted to a number with timing, that is to say after a duration of 1000 milliseconds, 1 second. This is all going to sound very familiar, believe me, I'm aware of that, so let's try and do it in a hurry. Again, we have given Reanimated what is essentially a destination for our height shared value. We've also given it the conditions by which it should iterate that value towards this destination. It has a duration, again, of 1 second, so we're looking at around 60 frames of animation, 60 iterations through this process. For the first frame, we update this height value. Let's say it changes from 1.83 to 1.8. We go through the dependency graph. What is dependent on the height? Again, BMI is derived directly from height as well as weight. Then we have BMI text, which is dependent on BMI, which is dependent on height. And then we have the viz style. So once these are all marked as dirty, we re-execute our worklets, starting with BMI. We are going up in BMI because we've reduced our height. Once that's executed, we move on to the BMI text. Change that to 27.1. And then we re-execute our viz style. We are still in this borderline orange area, but our width and height will have been updated. So once our values are all updated, again, our animated props are applied to our animated text input without a round trip to the JS thread. Our animated styles are applied to the animated view without a round trip to the JS thread, without going through React. With our second frame, we can very quickly go through the same process again. And finally, 60 frames later, we end up with this. A BMI 40, our shared values updated, our visualization blood red, and our BMI text reflecting that reality. Now, I kind of think that all this is interesting for its own sake, but from the point of view of an engineer consuming this library, there are probably 2 or 3 key takeaways here, I think. The first is, and this is potentially an obvious point, is the incredible amount of times that worklets potentially get executed. 60 frames per second for each derived value, for each animated element. There are potentially dozens of animated elements on your screen at any given time. There's a lot of traffic through these functions, so they need to be kept simple. A second potential point to raise would be the dependency graph. Now, what we have here is a very simple component, very simple set of animations, but it might be that in a more complicated component, you can optimize things such that most of the worklets aren't recalculated most of the time by thinking about how you use your shared values, how your derived values connect them up, and how they ultimately filter down into animated styles and animated props. A third thing to note that we as consumers of this library potentially don't think about enough is this additional JS runtime. For one thing, it's kind of an interesting pattern if you're developing a library yourself that does this sort of intensive work. But one of the things that you'll notice in a lot of React Native Reanimated code, take for example this expo template default file _layout.tsx, and you'll notice inside we have import React Native Reanimated. Not import a particular component from the library, but import the library itself. Now, I think my understanding is that the reason that you would want to do that is to spin up this JS thread so that your animations can get up and running as soon as possible. Potentially a pattern to consider for your use case somewhere near the root of your application. That's it. That's React Native Reanimated. As far as I understand it, the fundamentals of how it works. If you've got any constructive feedback, please let me know. If you're a library maintainer or expert user and I've got something important wrong in this video, please reach out. I'd love to make a correction. What I really want to do here is to learn in public and share those learnings, and a crucial part of that is going to be me getting some of the learnings wrong and making a fool of myself. But I prefer to be wrong for as short a time as possible. Thanks so much.